Across the remote landscapes of inland China, new arteries of steel and concrete are appearing at a speed that defies belief. Mountains are being pierced, valleys are being spanned, and even the sea itself is being reshaped. This isn't just construction, it's a revolution. For years, the world watched China's economic boom. But while we focused on finance and manufacturing, we may have missed a quieter, more fundamental shift. A technological leap so profound it has begun to redefine the limits of engineering itself. It's a revolution driven by machines, titans of metal and code so advanced they seem to belong to a future we have yet to build. How did this happen? What is the technology behind this unprecedented speed? And what does it mean when one nation masters the ability to build the world on a scale and at a pace never seen before? Our story begins with a machine known to engineers as the SLJ 900/32. To workers, it has a simpler, more fitting name: the Iron Monster. This is not a crane in the traditional sense. It's a 640-ton, 300-foot-long segmental bridge launcher. When a project requires crossing a chasm too deep or a site too inaccessible for conventional cranes, this leviathan is brought in. Its operation is a marvel of applied physics. The front of the machine cantilevers out, reaching across the void to the next support pier where it securely anchors itself. Then the process begins. An entire prefabricated bridge segment, weighing hundreds of tons, is transported along its length. The machine then lowers the segment with millimeter precision, locking it into place. Its genius lies in its self-sufficiency. Unlike a crane, which must repeatedly reach down to the ground, the Iron Monster carries its own segments, effectively building the path it travels upon. With 64 computer-controlled, fully rotating wheels, it inches forward onto the very section it just laid, ready to repeat the process. This machine was instrumental in projects like the Yibin-Guizhou high-speed railway, which cut a grueling 12-hour journey through mountain terrain to just 3. It's a solution to an impossible problem, but what it represents is only the beginning. To understand this revolution, we have to look deeper, literally. Beneath the Earth's surface, another battle is being won. For decades, the undisputed kings of tunnel-boring machine, or TBM technology, were Germany and the United States. Companies like Herrenknecht set the global standard. Before 2008, China didn't produce a single large-scale TBM. For every subway, every underwater passage, it had to import these multi-million-dollar behemoths. Then, a strategic shift occurred. While continuing to import, China's government tasked its top engineers with a singular mission: reverse engineer, innovate, and ultimately dominate the TBM industry. It was a quiet, undeclared technological war fought in research labs and testing sites. By 2016, the results were staggering. Chinese engineers unveiled the world's first TBM powered by a permanent magnet synchronous motor system, a leap in torque control and energy efficiency. They develop advanced, real-time geological survey systems, allowing the cutter head to adjust its pressure automatically based on whether it's grinding through hard granite or soft clay. Today, China's TBMs are breaking records. The Jinghai, at over 475 feet long and weighing nearly 5,000 tons, is boring one of the world's longest underwater highway tunnels beneath the Yangtze River. But its size is not its most impressive feature. The true innovation is in its metallurgy. Engineers at China Railway Construction Heavy Industry Corporation, tasked with building even larger machines, faced a fundamental limit. The immense pressure of the Earth would crush any TBM beyond a certain scale. The solution came not from a supercomputer, but from the ancient past. They studied the legendary sword of Gojian, a 2,500-year-old blade that remains remarkably sharp and corrosion-free. Its secret was a quenching technique using specialized clay to control the cooling rate, creating a unique crystalline structure in the metal. By adapting this ancient blacksmithing principle to modern industrial forging, they created a new alloy, one strong enough to withstand the forces required to build TBMs twice the weight of the Jinghai. Modern metallurgy, inspired by ancient wisdom. This mastery of the surface and the subterranean is now being deployed to the open ocean, where the line between engineering and geopolitics becomes dangerously blurred.
This is the MV Tien Kun Hao. At 460 feet, it is one of the world's most powerful cutter suction dredgers. Its official designation is for coastal restoration and port construction. Its nickname is more direct, the Island Maker. Its mechanics are brutally effective. A massive cutter head on a retractable arm descends to the seabed, pulverizing rock and soil. A powerful pump system then vacuums up the slurry and can discharge it over 9 miles away. Operating 24/7, it can dredge 6,000 cubic meters of material per hour, enough to create a soccer field buried 3 feet deep every 60 minutes. In days, a submerged reef can become a new island. Officially, this is for land reclamation, but in the contested waters of the South China Sea, its purpose is strategic. By creating artificial islands in disputed zones, China can attempt to build military outposts and unilaterally extend its maritime territorial claims, a source of intense friction with nations like the Philippines and Vietnam. The Tien Kun Hao is not just a machine, it's an instrument of statecraft, turning naval maps into new national territory. But perhaps the most visible symbol of this new industrial might is China's dominance in the art of the heavy lift. Their cranes are not just larger, they represent a fundamental shift in the philosophy of construction. Meet the XGC 88,000, the world's largest crawler crane. Standing nearly 500 feet tall, this mobile titan can lift 4,000 tons. Its modular design allows it to be disassembled, transported, and reassembled at the world's most demanding industrial sites. But even it is dwarfed by the gantry cranes. The Taisun crane set a world record by lifting a 20,133-ton module. Its successor, the Honghai, is engineered to lift 22,000 tons. These machines have revolutionized shipbuilding, allowing vast, multi-deck sections of supertankers and aircraft carriers to be built in a factory and then stacked like colossal Lego bricks. Out at sea, the Zhenhua 30, a floating crane ship, can hoist 12,000 tons, a capability essential for placing the immense pre-built tunnel sections of the Hong Kong-Zhuhai-Macau Bridge. And for the green energy revolution, wheeled cranes like the XCMG XCA 4000 are deployed in fleets. With a reach of over 500 feet, they can lift and install 28-ton wind turbine blades in a single fluid motion, accelerating the build-out of the world's largest wind farms. This industrial power is now merging with a digital revolution, creating a future of construction that seems taken from science fiction. The next phase is already here. It's called modular construction. Entire floors of apartment buildings and hospitals are prefabricated in factories, complete with wiring, plumbing, and windows. They are then transported to the site and assembled. A Chinese company famously erected a 10-story apartment building in just over 28 hours, a feat of logistics as much as construction. During the COVID-19 pandemic, this method allowed China to build a 1,000-bed hospital in just 10 days. Simultaneously, China is pioneering large-scale additive manufacturing, 3D printing for construction. Giant robotic arms, guided by computer models, extrude a composite of cement and recycled construction waste layer by layer to build everything from houses to public parks. 10 full-sized homes have been printed in a single day. The ultimate ambition? A project is underway to construct a 590-foot-tall hydroelectric dam built entirely by a fleet of 3D printing machines without a single human on site.
And that is the final piece of the puzzle. This isn't just about bigger machines, it's about smarter ones. China is creating the world's first fully autonomous construction sites. Excavators, bulldozers, and pavers are being equipped with sensors, remote controls, and AI brains. At projects like the Yangkou Dam, an AI system acts as the central foreman, dispatching autonomous machines to dig, move earth, and pour concrete, all without direct human intervention. For tasks that still require precision, specialized robots are being designed to lay bricks, plaster walls, and smooth concrete floors. We are witnessing the birth of a new paradigm, a construction industry that is faster, cheaper, safer, and cleaner, operating on a scale previously thought impossible. This revolution, from bridge builders that walk to tunnelers inspired by ancient swords to islands born from the seabed, is a testament to a national will focused on a single goal. It promises a world built with unprecedented efficiency. But as human hands are replaced by robotic arms and AI minds, we are left with a profound question. What is the human cost of this progress? And as one nation masters the art of building the future, what does that mean for the rest of the world? The Titans are here, and they are just getting started.